channel. I apologize for the weak audio in my previous video. I hope this one is much better. If you haven't seen my maiden video, please check it out. Basically, I'm attempting to write from scratch a database system in C. I'm using this textbook, Database System Concepts by Henry Korth and Abraham Silverschatz, as a guide. So let's get started. Our agenda for this video is to implement system data structures in C. We will also be coding three basic tools that will use these data structures: a sizeof data tool, a create, and a list tool. So as a review, we have said that in the previous video, I have identified three initial system data structures: a database structure, a table structure, and a column structure. For now, they will have common members or fields. ID, which will be a number between 1 to 255, a name, which will be a text or a string table will also have the same member, an ID and a name, and also for column, an ID and a name. As I have mentioned, we will be to link these structures together. We will introduce sort of a foreign key. For table, we will name it db_id, and this will link to the ID in the database. We have a similar one for column. Column will have an extra member called table_id, which we will use to link to a table. So in this way, they will have a relationship. It will be a relational model. One is to many. So one database can have several tables, and one table can have several columns. So let's fire up our code editor and start writing our first file. We will call it data.h. Now this file will be used for our structure templates, type definitions, macros, and other useful things that can be shared across different modules. So for now, we will just implement the data structure in the previous slide. So in C, we used the struct feature to group related variables together. So they will look like this. So for each data structure, we will just shorten the name. So struct db, struct tbl for table, struct call for column. Then let's introduce the first member. By the way, I will be mentioning members or fields. It will be interchangeable in this video. So the first member is ID. Now we have elected the variable type unsigned character or unsigned char for this. That is because, as we have mentioned in the previous video, our limitation for this project is 255. So a maximum of 255 databases in one system, maximum of 255 tables in one database, and a maximum of 255 columns in one table. So that's actually quite a lot already, and in post applications, this in at least for this project, that is plenty, and that's more than enough. So then we introduce the second member, common member for everybody, which is the name. So the name of the database, or the name of the table, or the name of the column. Now for this project, I chose the size to be 20. This is an arbitrary number. In your case, you can choose a lower or a higher number for that. So for this video, at least, we will set it to 20. And then, as we have mentioned, we will sort of introduce a foreign key. We will call it db_id for the table, and tbl_id for column. So since we will be linking them to the ID, they should have the same variable type. So dbid will link to ID, so we should have equal They should have the same variable type, and the same also for the case of table ID, which will link to tables ID. Okay, so save this file, and then we are now ready to write our first tool. We will name it sizeof.c. So it will be a very, very simple program. First, we need to include data.h. I am assuming that you saved both files, sizeof.c and data.h, in the same directory. So in that case, we will just use double quotes for our include. And then we will also include stdio.h because we will be using the printf function. Our main function will not take in command line parameters, so we will just use a void for its argument. And main will always have a return type of integer, so we will be returning 0 to the environment. So the first printf is actually because I like displaying data in table format. So this will be our table heading. So first is the struct, and then next is the bytes separated by 2 tabs, and then now the new line character. So for our first struct db, we want to get the size of that in bytes. So to get the size of that in bytes, we use the operator sizeof. Now remember, sizeof is an operator, not a function. It looks like a function, but in reality, it is a native operator in C. So it will return the number of bytes. You can specify a variable type here, or structure anything, a template, and it will compute the bytes for you. And this will be passed on to this format here, and then it will fall under bytes. So we will do the same for table, struct table. For column, we also specify here struct column. And let's see, we save this file, and then we compile it. I'm using a GCC compiler. As you can probably tell, I'm using a Mac. So assuming there are no errors, we run this this kind of command line format, and as you can see, the results are interesting. For db, the bytes is 21. For table, the bytes is 22. For column, the bytes is again 22. So why is that? Why is db 21 bytes but table and column have 22 bytes? So let's go back to our header file, the data.h. So remember that car in C is always 1 byte. So it is a simple counting of the bytes. So this is 1 byte, ID is 1 byte. Now this array of car is the size of 20. So if you add 20 plus 1, it's 21 bytes. Now it's almost the same here, except they have an extra member, which is sort of our foreign key. This is a typo. So if we add a 2, 21 bytes plus a third member, which is also 1 byte, so they are 22 bytes long. So if I just placed here in the comments the number of bytes based on the size of return, based on the size of tool. Now notice that if we add more members here, or we change the components here of each struct, the bytes will also be affected. So keep that in mind as we program in the future. So that's for the sizeof. Very, very simple and very, very handy. So just remember, every time you change data.h, you have to recompile sizeof, because it will not be updated even if you just save the source code of data.h but you don't recompile sizeof.c, then it will use the old values of data.h. So for a more interesting program, this is we will now attempt to create this tool. It will be a command line tool for adding database, and we will save it in a file called db.sch for schema. So how to use this program? We type in the name of the file, name create, then a keyword database, then the name of the database. So if you have been using SQL, I'm trying to mimic an SQL query of creating a database. So this will be useful again if you go back to our first video. We say that we are going to create a query parser in the future. So this will be building up to that level. But for now, it will be sort of an a command line tool. So one thing that we have to ensure is that the ID and the name of the new database is unique. So we should not we should check for duplicates. We cannot have the same ID number and the same database name in db.sch. So are you excited? So let's get coding again. So we create we create a new file called create.c, and in this file let's just write the bare minimum. So here we have the main function again, return type, which is integer, so we can return that to the environment. And instead of void this time, we specify two arguments. One is an integer for argument c, and one is an array of pointers, which actually points to strings. So if you would recall, argc contains a number of tokens basically in the command line. The first token is always the name of the file of the program, and then the subsequent tokens will be it depends on how many tokens are passed in the command line. So they will be pointed out. The first one, argv.0, will be the name of the program, the file name of the program, and then the subsequent token, so it will be tokenized. They will be broken up. The spaces will be ignored and will be broken up into tokens. So the spaces are treated as delimiters, and they will be pointed by argv. So long introduction. We will use the following header files. We will use stdio because we will be using a lot of file manipulation functions, and then we will also use string.h because we will be using string and memory related functions, and of course because we defined our data in data.h, so we will also include data.h. We will use the following local variables. For the first time now, we will declare a variable d of type struct db. So d will have id and will have name in it. Then, because we are going to open a file, so this structure or whatever it is defined in stdio.h. So file, we will need to declare a file pointer. So I'm calling the file pointer fp. And then we have two more local variables, and we will use later to get the return values of our file manipulation functions. And id will be used for our struct our id, our auto increment for our id database id. Okay, so very quickly, this block of code here, it's just going to check that this format is being used by the user. So it wants three things in the command line: create database, then the name of the database. So if it does not fit this format, it will tell the user this is the correct usage, and it will exit the program right away. As we have mentioned, we are going to use db.sch, so we are going to use the function fopen, and we are going to pass this mode, this type of mode for the file open, which is an append. This basically means that we are going to read the file, write the file, and if we write something into the file, it will be written at the end of the file. And the B here stands for binary. We are treating the file not as just an ordinary text file, but a binary file, so every byte counts. So when we invoke this function, it will return now a file pointer. It will store it in fp will now point to a file structure, basically. Okay, so every time we open a file, we should immediately write the closing of the file, because in C we have to explicitly declare these things. We have to explicitly state that once we are done with the file, we are ready to close the file, and the file will handlers and the file things that are in the background, the memory that was allocated, will be freed up. So these things have to be manually specified in C. So we will expand a portion of the code here, and just feel free to pause this video and write up this code. So just note that in the next slide we will be expanding the code around line 16. So here, from the previous slide, as I've said, we are going to open this file db.sch as an appendable file, as an appendable binary file. So after we've done that, here I just showed you a very important part of the algorithm. Basically, in this portion, we will be reading the file sequentially. So we will see that later on. So before we do that, we have to test always, if we are using pointers, we have to test that the pointer is valid. So to do this, we have to check if the pointer is null. If it is null, just tell the user that there's a problem reading db.sch, and we are now exiting the program. So let's get to a major part of the tool. So this is just to check if we have reached the end of the file. Normally, when at the start of the program, if there are existing things in the file, we will not immediately reach this one. But if it is a fresh file, if it's if it doesn't exist, then of course it will immediately satisfy that condition. So here, we are reading a record of size of struct B, which was 21 bytes, in file pointed to by FP, and we are storing the result in D, which is a struct DB. So basically, this is this function basically reads bytes from a file into memory, and then from that buffer, from that wherever it is saved, it will just copy a portion of that. It will copy, in this case, 21 bytes. If you remember, our size of struct DB was 21 bytes. So we are saying we want to copy one of 21 bytes into D, and fread will return the number of elements that it read. So if everything goes well, it should return 1, because we said we are only getting one element. If it returns another value, then there is an error. So in this portion, we now check if n is equal to 1, meaning to say that there's actually a database record in db.sch. We are now going to check. We are using a special version of strncmp, because this function, we can specify how many characters we our limit to our comparison, basically. So if there's an existing record, it says that compare the two now. If they are the same, then we tell the user it is already existing in db.sch and we cannot add that, so it exits the program immediately. So this whole portion here is simply a check on the duplication. So if there's no duplication, then we increment our ID. So remember, we start with 1. Now, if this is a fresh file, there's no record in db.sch, or it doesn't exist, it will not actually enter this while loop, and EID will remain as 1. But if there are existing databases already in db.sch, this will always be 1 more than the highest number there. So this somehow guarantees us that ID will be unique, because it will increment from the highest, the maximum ID that is in the db.sch. So here's an important workaround here. When I was programming this, I made many versions, and I realized I was missing something. So because I opened the file as a plus b, which is an append mode, it positions the file pointer almost up, just about the end of the file. So basically, when I run this command, it will not be able to pick up anything. So, but if we put an fseek here, this basically means to rewind the file pointer to the beginning of the file. Then we are able to read from the start of the file. So this is just the meaning of fseek, fp0, then seek set. Okay. So for the second half of the program, after we have checked for duplicates and determined the ID number, now we should check if the maximum databases have been reached. If ID is now 255 or more for some reason, then we should exit the program. We should not be able to add more databases to the system, because that was the limitation we imposed on our design. For this portion here, remember, because we had been using D to pick up records, so just to be on the safe side, we are flushing D. We are basically overwriting and everything in D to 0. This basically means that we are initializing D again. So for 21 bytes, we are going to write 0 on all those 21 bytes, because remember, sizeof in our current struct DB was 21 bytes. And here is the very, very important thing now. So remember, our ID would have the next available ID number, so it will pass it on to d.id. ID is the member of the field in D. And then we are using a special version of strncpy, string strncpy. The difference is that it will just restrict the string that to be copied up to 20 characters only, because remember, the user can enter any number of characters, maybe 30 characters for example, but we will only consider the first 20 of that. In this kind of program, it will truncate the characters that is more than it will ensure that it will be 20 or less only. So here we write whatever we saved here back to FP. So this is just the meaning of this whole thing. And again, we will do a check. I sort of did the reverse here. I could have written this better actually. I should have said if n is equal to 1, then it has successfully saved the database with this ID. Else there was an error. But since I wrote it that way, so you can just reverse it in your own program if you feel that's a better way of writing the code. So there you go. Let's see if this works. So let's compile create.c into a binary file called create. Then we run it like this only. And of course, it will complain that it needs the keyword database and the database name. Even if we type create database, then it will still complain because it needs a database name. So we specify a database called test1, and lo and behold, it says it has successfully saved test1. The ID number is 1 because it is the first in db.sch. But when we try adding it again, it does a duplicate check. So it says test1 already exists, so it does nothing. And then let's add 2 more databases, test2, test3, and then again, because there are no duplicates, so it has saved test2 and test3 with its corresponding ID of 2 and 3. Since we have not yet written the list program, one way to see the contents of db.sch is to use this Unix command cat, which is concatenate. It just basically prints out the contents of db.sch, and in order to make sense of that content, we pass it on, we pipe it into hex dump, and using this option here, we get this kind of output. So the more interesting, let's probably start on the right hand side. So if you can see, our test1, test2, and test3 are also saved here. And if you want to be very sure about it, you can actually count. This will count to 21 here, this will count to 22, and this will count to 22. So one character here is 1 byte. You won't be able to see the rest though, because they are considered unprintable characters. But if you check this byte here before t, this byte here before t, this byte here before t, this is actually 1, 2, and 3, because 74 is actually the hex representation of t. So more or less we can be assured that the file is actually saved correctly. So another test is we want to see how big is the file, how many bytes does it have. So if we do this command ls-l db.sch, you will see that it is 63 bytes. Why 63 bytes? I'm sorry, I need to correct myself. It should not be 22 bytes here. It all should be 21. This one will be 21, this one will be 21, this one will be 21. So if you total for every struct db, there are 21 bytes, so there are 3 of them. So 21 times 3 is 63 bytes. So so far we are correct. Okay, so that is for the create tool. Last but not least, we will also create a command line tool for listing the database in db.sch. It will have a similar syntax. It will be like this, list database, but the program is much simpler than the previous one. So here again, we specify the same header files. No problem, you already know about that. The arguments in main are very familiar to you at this moment. We will be using almost the same number of local variables. We don't need to keep track of the ID. And then this first block of code basically just checks the command line syntax. So if it's not equal to 2, then it will complain. Actually, you can already tell that this is not a strict comparison. There should be a more strict validation. I leave it up to you to validate the argument list. So again, we will be opening and closing the file, so we should have both functions written out already. But this time, instead on an a plus b, an append, we will just be reading the binary file. So we will not be writing anything. So we will say read plus b, r plus b. So we will expand now. Very similar thing. After opening the file, let's check if the pointer is valid. If it is invalid, if it is a null, then we exit the program and tell the user what was wrong. And then the printf here are the table headings again, because we will display the result in a table format. And inside this while loop, again, this is we are sequentially accessing. Now we didn't have to do an fseek for this program, because as it turns out, if we use R will immediately set the pointer to the beginning of the file, so we don't have to do an fseek. So this one, again, it's reading one record of db in fp and then storing the result in d. That's the meaning of this statement. And then we will again check if there are errors or not. If there are no errors, then we print the ID of the database and the name of the database. If there's an error, then it will print an error. So this is sort of a workaround as I was programming this. Apparently, the second to the last fread will not trigger an env file. There's one more fread which will be invalid, and after that fread, it will trigger an env file. So this is just sort of a secondary check on that the env file has not been reached yet. If it has been reached, then there's nothing else to do. So let's try this program. If we compile it, assuming no errors, and if we just run it without any arguments, without any options, then without any keyword, then it will remind the user to write it that way. That's just I forgot to include the dot backslash, and then here it is. If we run the program, then it will list down 1, 2, 3 the ID and then the database 1, 2, 3. So there you go. So what we have covered, many things. We have covered struct and sizeof. Just a little side information. There's a wonderful video out there of Brian Kernighan interviewing Ken Thompson. And if you don't know, Ken Thompson is the co-inventor of C and Unix, and he invented it. He wrote it. He invented it with Dennis Ritchie, basically. So Ken Thompson said that he failed to rewrite Unix in C 3 times until Dennis Ritchie introduced struct in C, the struct feature in C. So this is actually a very, very important and powerful feature in C, aside from pointers. So it's worth watching that video, and I think I watched it 2 times, and I like it because it's quite funny, but it's very very insightful too, of the genesis of C. So we also covered many file manipulation functions, some string functions, and then we wrote 3 tools in this video. So what's next? As I've said, maybe more command line validation. I did not validate the keyword database and other things, so it can be more robust. Let's think about future-proofing db.sch. What if we add more fields or members to the structure, so they will become misaligned if the file is already existing? So it's, I guess, no big deal when we're still developing, but thinking in the future, it might be problematic when db.sh is already existing. Then we will try to build tools for editing and deleting databases. So thank you very much for watching. It was really a pleasure doing this video. I enjoy teaching, and I actually taught programming many moons ago. So these days, of course, I have no access to a classroom, and so I'm just happy sharing what I know. So please, if you spot bugs or design problems or coding problems in my examples, in my code, please leave a comment. Please write it down, or and I will surely think about them and respond to them. And uh, yes, so see you in my next video. Thank you very much.